Hi everybody! In previous videos, I've talked about covalent compounds, ionic compounds, and acids. So I will not go over them in this video, but I have to go over what a base is. A base is any substance that releases an OH- ion. So, as you can see, I have strong bases and weak bases, just like there are strong acids and weak acids. So, let's talk about this for a second. A strong base will release OHs 100% of the time, or really close to that, which is why it's called a strong base. So, in this example, sodium hydroxide, a salt, is being dissociated into Na plus and OH minus. And the fact that this releases an OH minus means that it is a base. So let's look at what a weak base does. A weak base doesn't just, dissociate and release OH minus ions. It does something different. Most strong bases that we will cover in general chemistry are bases that are usually salts like NaOH being dissociated completely in solution. But usually weak bases will not do that. Instead, weak bases will ionize just like weak acids and strong acids do. So what do I mean by ionize? Well, NH3 will react with H2O in order to form NH4 plus and OH minus. So can we see what's happening over here? One H from H2O is being transferred to the NH3, which is why NH3 becomes NH4 plus. And when you transfer an H plus, you are basically transferring a positive charge to the NH3, which makes it NH4 plus. And by removing a positive charge on H2O, you're left with a hydroxide or an OH minus since you lost an H plus. So note that on both sides, the charges add up to 0, which is a good way to tell what the charges are. So if you gain an H, you become more positive, and if you lose an H, you become more negative. So in our example, NH3 added an H, so it became +1, and H2O lost an H, so it became -1. Now let me undo all this in order to clear up some space. So undo, 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 oops. I guess I can't undo anymore. But weak bases, unlike strong bases, will not ionize completely. Instead, they might ionize 1% of the time, as in the case for ammonia. And you'll learn this in the future about how acids and bases work, so don't worry about that in this video. This video is mainly talking about electrolytes, which we haven't talked about yet. So electrolytes are just chemicals or substances that become ions when they are put in water. So let me draw a diagram of, a water solution. And let's just say we have some Cl- ions and some Na plus ions. And notice this is when sodium chloride, NaCl, dissociates in water. So in our picture, we can put two pieces of metal to show what an electrolyte does, and this might be a wire. So what an electrolyte does is that it allows for the flow of electricity through the solution. So when you have freely moving ions, such as Cl- and Na+, electrons are able to basically move on to these ions and move around, because without these ions, these electrons can't move around, because you would have neutrally charged water molecules, which cannot conduct electricity very well. So having charged particles allows electrons to freely move around the solution and thus create a complete circuit, which is why electrolytes conduct electricity. So if I put a light bulb here, this light bulb will light up because the solution conducts electricity. So let's now go back to our list. All ionic compounds, which are salts, will fully dissociate into ions in water. And because they dissociate completely into ions, they are called strong electrolytes, because a strong electrolyte is a substance that completely dissociates or ionizes into ions, and thus it's a single arrow. So here we have a single arrow indicating that this process only goes one way, and it goes nearly 100%. So that's what a strong electrolyte is. Now, let's find the other things that are strong electrolytes. Let's take a look at strong acids. So a strong acid like HCl will start off as a gas, and then this blue arrow indicates that it's being dissolved and turning into aqueous. So it'll turn into HCl aqueous, but almost immediately it will ionize into H plus and Cl minus in their aqueous form. And that's why we have a single arrow, which means this is also a strong electrolyte. Since you are producing charged particles, you have a single arrow, and thus you are a strong electrolyte. Now, let's take a look at a strong base. In a strong base, the NaOH salt will completely dissociate in water and turn aqueous, and once it dissolves, it'll immediately separate into Na plus and OH minus. And since these are charged particles and it's a single arrow, meaning it goes to completion, so 100% means completion, then strong bases are strong electrolytes. Now let's look at what weak electrolytes are. Weak electrolytes will produce charged particles, but they will not go 100% of the way, and that is indicated by a double arrow. So weak acids, such as hydrogen fluoride gas, will dissolve in water, and thus a blue arrow, meaning dissolved in water, and then it will maybe transform into some H pluses and F minuses in water, but since it is a double arrow, it means this does not go to completion. In fact, only 10% of the HF might turn into H plus and F minus, and that's why there's a double arrow. So as a result, weak acids are weak electrolytes. And for the same reason, weak bases are also weak electrolytes, since we can take a weak base like ammonia, gas, and it will transform into an aqueous form of ammonia once it's dissolved in water, indicated by the blue arrow, and then it might react with water, and maybe 1% of it will be converted into NH4 plus and OH minus. So since it isn't all the way, and since we have a double arrow and we have charged particles, then this is a weak electrolyte. Now let's look at what non-electrolytes are. Non-electrolytes do not produce any charged particles. So let me erase carbon dioxide, since I kind of realized that carbon dioxide can actually produce charged particles, but we're not going to talk about that. Let's do some other covalent compound, like CH4, famously known as methane. So methane gas, although in very small quantities, might dissolve just a little bit and turn into CH4 aqueous. So CH4 aqueous obviously will not produce any ions, since it is neither a base nor an acid nor a salt. So since in water CH4 just remains CH4 in its aqueous form and it's uncharged, we call covalent compounds that dissolve in water non-electrolytes 99.9% of the time. So let's do a brief overcap of everything. Covalent compounds are 99.9% of the time non-electrolytes. Strong acids and strong bases are strong electrolytes. And weak acids and weak bases are weak electrolytes. And last but not least, salts are strong electrolytes. And let's read the note that I wrote. Regardless of their solubility, if a salt dissolves, it will fully dissociate into ions. So a weak acid might go into solution, such as, HF going into solution and becoming HF aqueous. But if HF aqueous chooses not to dissociate fully into H plus and F minus, we call it a weak electrolyte. Meanwhile, if NaCl chooses to go into water, it will 100% dissociate. So if you have a single arrow, you are a strong electrolyte. If you have a double arrow, you are a weak electrolyte. So let's talk about the conductivity of strong electrolytes, weak electrolytes, and non-electrolytes. Let's take a look at this picture. Actually, let's draw another one. Let's draw 3 situations, and let's draw some water. And let's say this has a strong electrolyte. Then you will have lots of ions in solution, and thus, when you put a circuit, you will conduct electricity, and the light bulb will light up very brightly. Now, what if this is a weak electrolyte? Well, if you're a weak electrolyte, like a weak base or a weak acid, you will not ionize completely, and you might ionize just a little bit, so you'll have less positive and negative ions, and as a result, when you put a circuit through, the light bulb will not be as bright. So let me undo some of that. It will be not that bright. So this is brightest, and this is not so bright. And what about non-electrolytes? Well, in a non-electrolyte solution, for example, if you dissolved sugar, for example, which is a covalent compound, oops, that's not how you spell sugar. This is how you spell sugar. Sugar will not dissociate or ionize into any ions, so this water will remain, for the most part, uncharged. And as a result, if you put a wire and you have a light bulb, your light bulb will not light up. So this will be not bright at all. So let me go back to the point I made earlier. Regardless of the solubility of a salt, as long as a salt dissolves, it will be a strong electrolyte. And since all salts dissolve no matter what you are, it just depends on, how much dissolves, but all salts dissolve. So let me write that in big letters. All salts dissolve to some degree. So if a salt dissolves, which they all do, by the way, then they are strong electrolytes. So have a nice day, and thanks for watching.